If you enjoy fishing, you've probably seen Tasmania's short-finned eel in some of our rivers and dams. This extraordinary creature has a remarkable life cycle, and in this video we share with you how Hydro Tasmania helped elvers, baby eels, and eels conquer the Trevally Dam. Using science, technology, engineering and maths, our people working in teams developed a solution to help eels migrate past the dam. If you've ever wondered how STEM skills will be useful for a career, just keep watching. Since 1895, water from the South Esk River near Launceston is used to drive machines that generate renewable energy. The water then flows into the Canamalooka-Tamar River, which is an estuary that runs into Bass Strait. Each summer, thousands of elvers migrate upstream and eels migrate downstream.
Hello, my name's Dave Aketefei and I'm an aquatic scientist with Hydro Tasmania. My job involves making sure our operations, the way we run our waterways and power stations, looks after all the living things in our waterways such as plants and fish and insects. So one of the most fascinating creatures we have in our waterways are our short-fin eels. They're a migratory species, which means they have to move from fresh water to the sea to breed. They travel all the way up to the Coral Sea off the coast of Queensland, which is many thousands of kilometres, to spawn. And once they've spawned, they die. Their eggs then hatch out into what are called leptocephali, which means like a leaf-like larvae. And those larvae then start their journey back southwards on the East Australia Current. And when they get to southeastern Australia, or in our case to the mouth of the Tamar estuary, they metamorphose or change into what are called glass eels, which are little miniature eels that are totally see-through. And those glass eels come into the estuary and actively swim upstream, and they then change again or metamorphose into what are called elvers or juvenile eels. They're fantastic climbers, which enables them to climb all the way up into the rivers and up into the headwater streams to colonise our catchments. And they'll start there until they mature, and then they'll do the whole process again, the migration out to sea as mature adults.
Many years ago, through using science and technology, a solution was found to enable elvers to climb the side of the dam wall. David shares how this was achieved.
Unfortunately, our dams block their ability to move between the rivers and the sea. So back in the 1990s, we built what was called an elver ladder. It's essentially a fish ladder designed for juvenile eels to get them up and over the dam. And since that time, it's worked fantastically. It's passes hundreds of thousands of juvenile eels each year.
While the elvers were happily swimming upstream, we needed to turn our attention to helping the eels get downstream.
We then faced the problem of, well, we know that those juveniles will grow into adults and have to move downstream back out to the ocean. And the only way to do that is either to go over the dam during spill, which doesn't happen very often, or through the power station. And that's very problematic because the power station has spinning turbines which kill eels, and we do see dead eels in the tail race each migration season. So while you can find fish ladders on mainland Australia and elsewhere in the world, there's nothing that really works well for eels. So we had to figure out what we could do to get them downstream. So we used a sonar, which is like a depth sounder on a boat, so we could watch them underwater 24 hours a day to watch their behaviour around the intake. And then we used little tags that we implanted. They're only very small, about that kind of size. Implanted them inside the eel, and they tracked the movement of the eel, so we could see where the eels were going. And there were a couple of things that stood out that really gave us the green light to build the bypass, and that was that eels really weren't keen to go down into the power station intake, and that they were searching around the dam for an alternative way to go out. And one corner in particular was really popular, and so that gave us the idea that if we could release water at that point through the dam downstream, we'd be able to get the eels downstream successfully. Trevally Dam is really interesting in that it has a lot of people who live around the dam, and a lot of people go there to kayak and to mountain bike around the edges, and also to go boating and skiing. So it was really important for us to talk to the local community to let them know what we'd like to do to get our eels downstream, and that there will be construction activity going on, and just to reassure them that when they see water coming out of the dam when the project's finished, that it'll be safe. It's meant to be there. So we have specialist people that go and talk to the community and get their ideas and concerns and thoughts, but also let them know what we plan to do and why we plan to do it. So once we'd identified that there was potential to build a bypass in this corner, that was where, I'm just a biologist and I don't deal with structures, and that's where I needed to get the expertise of engineers involved to understand, well, could we drill a hole in the dam? And if so, how could we design it such that we could release just the right amount of water to attract the eels and also to get them downstream safely?
I'm Jay Runciman. I'm a mechanical engineer. I work for Intura, and I was one of the people here at Intura that completed the detailed design for the eel box. Well, we had to take Dave's ideas and then put that into pictures and drawings on the computer to be able to show Dave what it was going to look like, how it was going to work, how it was going to go together. Then once everyone's happy with it, and after that we can put it into a set of plans essentially that everyone can work to.
And I just found it so much fun, talking to people about an idea, and sometimes you'd have an idea about a particular aspect and the engineers would go, well, actually, that's not going to work, but if we do it this way, it will work. And that was a really fun part of the job, and it was really rewarding.
My name's Andrew. I've been working for Hydro Tasmania for about 12 years. I'm a project manager, and my job is to get people to do work on some of the power stations, the dams, the canals that Hydro owns. So you can't buy a drilling platform from a hardware store. That had to be made, the same as the intake box had to be made specifically for this job.
I'm Ben from Saunderson Ward, and I'm responsible for looking after the eel project, for building all the bits and pieces that we supplied for the Trevellyn Dam.
And I'm Brett. I'm responsible for putting all the stuff that Ben made here in the workshop onto the site and making it all work.
So teamwork is absolutely critical to any project like this. So in a lifting scenario, to make things safe, they need to have teamwork to coordinate, but with the whole build itself, it's like a chain with lots of little links, and you don't have one continuous chain if those links are broken. So, the part on site working as a team, here in the workshop working as a team, working with the other contractors, we all need to work together as a team to get the outcome that we want.
So this job was a bit tricky. The first thing we had to do was to build a road so we could get a crane down to the dam. Then for the drilling we had to put a platform in, and to get the workers to the platform safely we had to put some scaffold in. So that was put some handrails on to stop them falling over some edges, and also some steps so they could get down safely and easily. So the dam is really high and it's really steep. Now all of that steelwork's really heavy, so we had to get this pretty decent sized crane in so that we could lift everything in place. There's also some big pipes that had to be moved around, and even some workers were being moved around in a workbox.
Cranes these days are pretty easy. They're just like playing on a PlayStation or computer at home. A couple of joysticks for your boom and wires, and it's not a practical sort of job, but it's more your mind.
One of the jobs in the rigging is selecting the right gear for the weight of the loads. You got the right size slings, the right size chains, and hooking them up so they don't slip.
So the drilling was really hard. We couldn't get a really big drill in there. Also, drilling horizontally is much harder than drilling straight down. So we also had to put some more big pipes on the lake side of the dam. Now, we couldn't take the lake level right down because the power station's operating. But what we could do was get divers involved. The crane would pick up the pipes, carry them into the lake, lower them down, and then the divers had to move them around underwater and fix them in place.
So the commercial gear we use are full helmets. It's got speakers and a microphone in the helmet. We have lights and a camera on the helmet, so we can see on the surface what the diver's doing, talk to the diver, he can talk to us. Visibility on the lake isn't very good here, it's probably 1/2 a metre. We do a lot of construction work for the hydro, and drilling, cutting, chainsawing, pretty well everything you do on the surface we can do underwater.
All in all, it's been quite a tricky project, but it's come together really well. Everyone's worked together really nicely on this one.
After the construction was completed, the next step was to commission the bypass, which means putting water through it. So we lifted the dam, or the water level in the lake, back up to its operating level and released water down through the bypass. And it was such an exciting time. It was fantastic to watch the water coming out as per the design, and it just looked like a natural cascade going down the dam wall. So it was a very exciting part of the project, seeing those first flows run through the bypass. So one of the steps we used in testing was to use what's called a sensor fish, which is like the size of your thumb, and it's like a little electronic measuring device, kind of like a Wii controller. So it detects movement and shocks and pressure changes, and we put them through the bypass just to make sure that it's safe for eels to go through. They're very expensive, and before we put them through the bypass, we used, of all things, fruit and vegetables, mainly because they're a similar kind of hardness to eels, just to test that they would get through to the other end and we could collect them, so that when it came time to use the sensor fish, we could make sure that we could pick it up at the other end of the bypass once it had passed through.
David and Andy, who's also a scientist, returned to the dam in summer and set up an eel net at the bottom of the wall. Did they catch any eels?
We just done a night's netting, so that's where we put a net at the bottom end of the bypass to see what's come through the night before. Last night we got a catch of 57 migrating eels. So we generally just check the condition of the fish as well as counting them, and we weigh a subsample. But no, it's a fantastic result. The first part was building the Elva ladder to get the juvenile eels up and over this dam, and then to tackle the problem of getting the adults down so they can access the South Esk, the lower parts of the South Esk and the Tamar and onto the Coral Sea. And to know that we've done all that we can to get them up into the catchment and back down again is it's just unbelievably fulfilling.
That is one very happy aquatic scientist, and the eels are pretty ecstatic too. Remember, it wasn't one person who solved this problem, but a team of people. Some had science skills, others technology, while others are problem solvers. And some had brilliant math skills. Will you use your STEM skills to make a difference?
Hey Dave.
What?
What did the eel say when it swam into a lump of concrete?
I don't know, what did it say?
Damn.